Hey, welcome back to Fan Mama Physics. In this video, we're going to do the second half of 5.5 using the slope y-intercept form, which means I can probably do everything in the one video, assuming that there shouldn't be too much problems in determining any of the equations. However, you might notice that for example 1, we can't really use a slope y-intercept form because the graph itself is discrete. It's not continuous, meaning we can't really draw a line. So, but maybe what we can do is we can complete the dots. And I guess I should have talked about this in this last video, but kind of did. Because if you take a look at this question, Jana's borrowing money from her parents for a school trip. She repays the loan by making regular weekly payments. So every week she's paying her parents a certain amount of money, and the graph shows how she is paying her parents over time. The data are discrete because payments are made every week. So we can actually take this graph and we can take a look at how much she would pay per week. So again, I mentioned this last video, ignore that line there. It doesn't make sense. If you want, I can draw a better one. So just look at the blue line. Don't look at the rest of those green lines. They are meaningless. But again, let's plot her payments every week. So the first week, 0 weeks, it will be there. Then it will be there. After 2 weeks, 3 weeks, 4 weeks, 5, 6, 7, 8, 9, and finally, looks like 10 weeks, the amount she owes goes down to 0. Okay, so notice in our x-axis, it shows us the time, and the y-axis shows you how much money she owes. So we probably only need to just read this graph to finish this question. And again, we can't use a y-intercept form for this question because the data points are discrete. So let's we can just read the graph. But what we can do is we can figure out kind of like it's a rate. I wouldn't say it's a slope because it's not a line that we're looking for the slope of. The rate of which she pays money, if you take a look, is every week she drops down 1 box on this graph. 1 box, if we take a look, it goes from 200 to 160 for the 2 boxes. So 1 box is halfway, 180. So 200 to 180, that's $20. Every week she is paying $20. We probably will need that for this question. Maybe I'll write it one here. That's the rate of which she's paying her parents back. How much money did she originally borrow? If you think about it, that's kind of like when time is 0, pretty much where the graph intersects the y-axis. So this is like your y-intercept. So for your slope y-intercept form. So on the y-intercept, notice that the time is 0. That's when she got her money. That's where she got her loan. And how much she borrowed? This is $200. Okay. How much money does she owe after 3 weeks? So we can directly use this graph to answer this question. So for at 3 weeks, she still owes halfway between 160 and 20 is $140. Or you can use this rate over here. After 3 weeks, she's gonna pay $60 back. $60 minus the 120 is going to give you $140. So I can write it up here. 200 minus 3 times $20. This is 140. Okay. Next one. How many weeks will it take Jana to repay half of the money she borrowed? So again, you could use the graph, meaning take a look at 200. Half of the amount would be $100. So you go, okay, $100, go across the graph, bam, intersects there, going down, that's 5 weeks. So we can just do that. Or we can take a look at the rate again. We know that Jana borrowed $200. Half of $200 is $100. So if we take $100 and divide it by the $20 she pays per week, we can figure out how many weeks that is, which is 5 weeks. So again, you can use the rate, just like how you can use a slope to figure out values later on. Okay? So, so if I had a y-intercept form, an equation, it would just look like this. If you try to think of one, hypothetically, actually here, I'll write a note here. Hypothetically, if Jana paid her parents every second. So what that means is that she's continuously paying her money back. It's as if she put the money in the bank, and the bank just sent these strands of data of money of the currency to her parents' account slowly for 1 week. I'm sure someone's gonna hack the computer and to just take that. I don't know. Just making the stuff up. But hypothetically, if she continuously paid her parents $20 throughout the week, paying bits of coins, of cents or whatever every second, and which means the graph would be continuous, it would be really crazy and it's not really possible. But let's say hypothetically, if that were the case, if we have a continuous graph, then our y-intercept equation will look like this. We have y is equal to, we just found the slope. The slope would be negative because it's going down, and she's paying her parents, so she's losing $20 every week, at which W is the number of weeks, meaning after 1 week she pays 20, after 2 weeks she pays 40, plus the 200 that she has to owe, meaning every week she's going to subtract $20 from the amount that she owes. So that would be our slope y-intercept equation if the graph was continuous. Okay, next up we have Maya. This Maya question. And this using y-intercept form for this graph is perfect because of the fact that we can't even extend this line to 2,000 meters where we need to extrapolate the data. So we just need to use this graph here to figure out this y-intercept equation. Y equals mx plus b, where b is the y-intercept. That's very easy. It's right here. The y-intercept is at 0. It intersects at the origin. So b is equal to 0. What about the slope? Slope, again, it was your rise over your run. So our rise, I'm going to pick this origin point, and I'm going to pick this point up here because the dots are one, far away, and two, they lie exactly on the grid line. So it's easy to use here to figure out the rise. So rise is 1,200 meters. Our run, which I'm going to do in blue, is from here all the way to there. Our run is 10 minutes. So that when we figure out the slope, which is rise over run, then we have 1,200 meters divided by 10 minutes, giving us 120 meters per minute. And just like the last video, it's like finding out how much she can run after 1 minute. It's the rate that we're talking about. Using the rate can help us answer a lot of questions. So this y-intercept form is basically giving structure to the conceptual understanding that you should get from this graph. And having a structure is very nice. You can just blow through it instead of, because we know it works. Once you understand that it works, you just have to grind through the questions, as you say. So here we have 120 times our x. Oh, I'm running out of space here, so I'm just going to write it. I'm going to write it directly on the graph here. Y equals 120x plus 0 because the y-intercept is 0. So it's just y equals 120x. A, predict how long it would take Maya to jog 2,000 meters. And for A, this one is giving us the distance. So that's on our y-axis, meaning if I use my slope-intercept form, then 200 would be my y, and I would have that equal to 120 x here. And then maybe I'll get rid of the m so it doesn't confuse you. M is just the units, okay? Okay, so then we want to figure out the x, so we divide both sides by 120. we get a number that is 16.666, just like in the previous video. Whoopsies. And 6 is repeated. Our answer is X, which is minutes. Okay, next up we have predict how far Maya will jog in 14 minutes. So this is a value of time, and time is along our x-axis, which I'm going to substitute as x into my y equals mx equation. So y is equal to 120 times 14, in which I am going to get 1,680 meters. So notice once you have the equation, everything is so easy. What assumption did you make? Well, assuming that the pattern continues on this graph, which is the slope, and there's no way to change where she started, but if we have to extrapolate here, we kind of have to assume that she continues her average speed. And the fact that she maintains somewhat of her average speed does not really fluctuate even during this 0 to 10 minutes, which on the graph it doesn't. But assuming that she continues at this average speed, and that her average speed doesn't, or her speed at any one point doesn't really fluctuate a lot, then we can make these predictions safely. Like she can go at some average speed, but her speed could be everywhere within that second or whatnot. Then that would be kind of disruptive in our graph. Then even though graph roughly shows a straight line, it might show some jagged lines later, even though it looks like the trend is pretty much straight. But yes, it means that she continues to jog at this average speed without too many fluctuations. I'm just gonna write without too much flux. Okay, because I'm running out of space. Okay, last equation here. So guess what? This is a great one to use for y-intercept form, and I would also recommend that you try this video yourself. Try this example yourself by pausing the video. Okay, now let's do this question together. So slope y-intercept form, y equals to mx plus b. This time, b is no longer, the y-intercept is no longer the origin. It intersects right here on the graph, in which it is between 4 and 6, meaning b is 3. Okay? So, b is 5. What am I doing? Okay, b is 5. So, next up we have our slope we have to figure out. So again, we're going to take 2 points on our graph, but it seems like the slope is pretty consistent, because if you take a look, and according to the last video we also showed this, every time it goes down by 1, so that's or actually it's going up, to be fair. The graph is going up from left to right, so it's actually going up. The reason why I was going down in the previous video is because I was working backwards. So it goes up 1 unit. Okay, so it goes up 1 unit as we move across, and also as well moving up. Okay, and then moving across, it is moving 3 spaces across. So it has a run of 3 and a rise of 1. Plus 3, plus 3. So our slope here is pretty consistent. I don't need to pick 2 points to make myself go crazy. The slope here is, my rise is 1, my run is 3. So it's just simply m is equal to 1 over 3. So if I write my equation down here, y is equal to 1 over 3 times x plus 5. That is my equation. So using this equation, we can determine the value of x and y is equal to 3. Now, this one is tricky if you had to extend the line, but with the y-intercept, it might be a little bit easier. So let's plug 3 into our equation. We are going to get 3 as y, so that's 3, is equal to 1 over 3x plus 5. So using a bit of algebra, we're going to move the 5 over by subtracting 5 on both sides. And we are going to get negative 2 is equal to 1 over 3x, in which the last step is just to multiply both sides by 3. we're going to get x is equal to -6. Okay? So I don't know what you think of that. If drawing this part of the graph and extrapolating the line versus grabbing y-intercept slope and finding out using the equation. Now you have two ways to do this. So let's do B. Looks like B might be better using a graph because it's very clear about what the slope is, but to be more precise, we can use our equation. When x is equal to 5, so we can just plug this one in. We have 5 is equal to x, and this is plus 5. So we're going to get something like 5 over 3 plus 5. And if we want to be a little bit nicer to ourselves, we can just plug it into the calculator, which in our case is 6.666. Oh wow, I predicted it very nicely, 6.6. Or if we want to do it using fractions, this is 5 over 3. So if I could convert that to a mixed number. I get 5 plus 1 and 2/3. So 5 plus 1 is 6. 2/3 is 0.6666666. Okay, so that's one way to think about that. Last one is C. What's the value of y when x is equal to 1? This one should be much easier. 1 over 3 times 1 plus 5, which is going to be 5 plus 1 over 3. I just changed the order of the addition, and that's just going to be 5.33333 because 1 over 3 is just 33333 repeated. There you go. These are the last two questions. So it seems a little bit easier, like just doing the number, putting the numbers into the equation might be a lot easier to get your exact value versus trying to estimate on a graph, okay? That's the beauty, again, of your slope y-intercept form. So I hope you find it useful and hope you like this form, and we'll be able to put into practice. Thank you for watching the video. I wish you good luck on that. Fan Mom Physics signing out.